So we're going to move on to Unit 4, Lesson 6. Okay, we're going to be learning case analysis. So just a little, kind of just did this because I did Lesson 7 a second ago, but we are compiling a list of strategies or tools to solve systems. We've done by graphing. Okay, today we're doing case analysis. And then tomorrow we're doing sign analysis. Those are going to be the three types of ways we can figure out the system of equations solutions. Okay, so building off of that, quadratic inequality with one variable. So it means there's no y. When there's no y, we're not shading, we're not doing any of that. We're trying to figure out when the actual graph itself is positive or when it's negative. Okay, so it looks in like these forms here. Okay, so let's get down here to this example. So, solving quadratic inequalities by graphing. So, just, kind of building up what we've already talked about. Let me see if I can move this up just a little bit more. Okay, that's perfect. Okay, so, just going through here. Says x squared plus 2x minus 8 is greater than 0, and x squared plus 2x minus 8 is less than 0 are quadratic inequalities whose solutions can be determined from the graph of the associated function x squared plus 2x minus 8. Just really quickly, down here I already told those zeros, let's factor this for practice. You should have x plus 4, x minus 2, which yields zeros of negative 4 and 2. And that's why the graph right here is going through negative 4 and 2. Okay? So the x coordinates of the the x coordinates of the points on the graph, which are above the x-axis, give the solution greater than 0, because it's talking about the y being greater than 0 in terms of the value. So an easier way to think about this is when you see greater than 0, think positive. So where in this picture is the parabola positive? Well, it's positive up here and up here. That's the positive parts of the graph. And then for the next part, it says, where is it negative? So that would be this part. This part's in the negatives. Okay? When I say negatives, I mean underneath the x-axis here. That part is your negative part. Okay? And then this part is your positive, your green part. Okay? That's above the x-axis. So when you're classifying these parabolas, you're talking about the pieces in which are positive and which are negative. And make sure, too, to understand this for tomorrow, is that there's three pieces here. There's this piece, that's 1. There's this piece, the u, this piece, 2. And then there's this piece, 3. So you have 1 piece, 2 piece, 3 piece. Okay? So let's look here at example 1. So complete the following using the above graph. So the solution to the inequality for when it's greater than 0, the green, was, if you think about it, it was the outsides. So it was x, sorry about that, it was x less than negative 4, x greater than 2, and it was negative in between those two. So greater than negative 4, less than 2 is when it was negative. Okay, so this would be, right here, is the number line example of this. This one right here is a number line example of this. So as you can see, it's going this way, it's going outside, and in here it's going inside, it's in between. It's simply easier to think about this, is it outside or in between? That's how your parabolas will be, the patterns will yield an outside or in-between relationship. Okay, let's look at example 2 here. So in example 2, it's got it written backwards, but we can still factor that. So 12 plus 4x minus x. So just know that your x's are going to be in the back, and one's positive and one's negative because you got negative x squared. Now you got to think of factors of 12 that are 4 apart. Well, that's 6 and 2. We want a positive 6 and a negative 2. And why I put them there is because the 6 is actually going to times that x. The 2 is going to times the negative x. So that will give me 4x. So that is your factors right there. So by having that, that gets me my zeros. My zeros are -2 and 6. So I know that my graph is going through here and here. I know my y-intercept is 12. Okay, and I know my graph is going downward parabola because it's a -x squared. So my parabola should look something along these lines. Okay, so we're going to go ahead and solve the inequality. So by using the graph, so if I look at it, it says, let's go back here really quickly, it says it wants to be greater than equal to 0. That means I want the positive part of the graph. Well, this graph's flipped this time, so it is a little bit different, but still, all I have to do is highlight the parts above the x-axis. That is the part that is above 0. Now, what does that mean? Well, that is now the in-between section. Okay, so between -2 and, 6 is positive for our parabola. So that would be, for our number line, we want in between. So we'd want -2, 6. I want equal to, because it's equal to right here. So I'm going to have a solid dot, and then I'm going to go ahead and just highlight in between. That would be the answer there. So state the solution to the inequality. Okay, so the solution to the inequality, that just means write it out. State the solution. It would be x greater than equal to -2 and x less than equal to 6. Now you can also write that as an in-between answer, which the book likes to do, like that. That's how you write in between. And if you get used to that, because that's just how math is going to do in-between answers. That's just kind of something you need to get used to. All right. Okay, let's go ahead and investigate the problem here at the bottom and see what we can figure out here. Okay, so Colin wondered if he could solve the inequality x squared plus 2x minus 8, which he recognized we've already done this one, but now we're going to do it without using a graph. So his work is shown. So what he did was he did x squared plus 2x minus 8 is greater than 0, broke it down, and then he did x plus 4 greater than 0 and x minus 2 greater than 0. And so what works for both of those is x greater than 2, okay, because x greater than 2 is good for x greater than -4. What I mean by that is if I look at a number line, I have -4 here, I have 2 here. If I do greater than 2, every number 2 or greater works for x greater than -4. But if I just put -4, this area does not work for x greater than 2. So that's the one that works for both of them, is x greater than 2. So this is one of his answers. And then it says since x has to be both greater than -4 and greater than 2, he concluded that the solution was x greater than 2. When he checked his answer, he discovered he only had part of the solution, so he's still missing a piece. And this is part of the investigation. Colin's answer is incomplete because going from line 2 to line 3, Colin concluded that if the product of two quantities is positive. So this part right here, he's saying x plus 4 is positive, greater than 0. He's saying x minus 2 is positive, greater than 0, because a positive times a positive equals a positive. Well, that's what we want. We want a positive number, right? Something greater than 0. But there is another way to get a positive answer, and it would be negative times a negative. So in order for Colin to finish his, he's going to have to flip his inequalities to make them say less than 0, because minus times a minus is a positive. So we'll do that here in a second. So describe the other case that Colin did not think about when he went from line 2 to line 3. We just discovered it. A negative times a negative also equals positive. So we have positive times positive equals positive, negative times negative equals positive. That's the ones we didn't consider. Determine the complete solution to the inequality. So he already has the first answer. He has the x greater than 2. We need to figure out the other part. And all you have to do to figure out the other part is switch the signs. So it's going to be x plus 4 less than 0, x minus 2 less than need to solve those quickly. X less than -4, x less than 2. So if it's x less than 2 and x less than -4, then -4 is the one that works for both. So now you have your two answers. And that makes sense because it's what we got when we did on our graph earlier. If you want to go back and peek at that real quick, we got greater than 2, less than -4. We got the outside pieces because our graph is doing something like this. So we want this section. Should use a different color here. Let's just use the highlighter. We want this section and this section, which is the outside sections. Okay? All right, so let's try this one here. So solve the inequality x squared minus x minus 20 by an algebraic process similar to the investigation on the previous page. So this time, we're looking at x squared minus x minus 20. So the first thing I want to do every time is I want to go ahead and factor them. So by factoring that, that's going to give me x minus 5. Whoops, don't want a highlighter here. I want x minus 5. I want x plus 4. And it's less than or equal to 0. Well, less than or equal to 0 means negative. Well, last time we were doing positive. In positives, we said for positives, we wanted plus times plus or negative times negative. That gives us a positive answer. Well, for a negative answer, it has to be these two, negative times positive or positive times negative. That gives us negative answers. It's only 4 options you have. Okay, and so what we're going to do is I have to do 2 cases. That's why it's called case analysis. So we're going to do x minus 5 being positive and x plus 4 being negative. And I'm going to do x minus 5 being negative and x plus 4 being positive. That's my 2 cases for when the whole answer will be negative. And we just quickly solve. I'm going to get x greater than or equal to 5, x less than or equal to -4. I'm going to get x less than or equal to 5, and x greater than or equal to -4. So there's my answers. So now we have to look at this in the case because this is saying greater than 5 but less than -4. That's talking about the outside part of the graph. This is saying less than 5, greater than -4. This is talking about the inside. So one of these is false, okay, or no solution. So what you can do is one of these will be the answer and one won't. So what we're going to do is we're going to figure out which one is, which one isn't. So I'm going to find something. I'm going to take a number bigger than 5. I'm going to take 6. And I'm going to plug 6 in right here for x, right here and here. So, and figure out if it's a true statement or not. So is 6 minus 5 is 1. 6 plus 4 is 10. 10 times 1 is 10. Is 10 less than or equal to 0? Absolutely not. So we will cross this out. This is my no solution section. Or just this was not the right answer. So conversely, if we go over here, this one is my right answer. And we will confirm that really quickly so you don't just take my word for it. So let's go between 5 and -4. Just do 0. 0 is easy. If I put a 0 in here, I get -5. If I put a 0 in here, I get 4. -5 times 4 is -20. Is -20 less than or equal to 0? It is. So we just confirm that this right here is our answer. So we want, and again, I told you write it in between if it is in between. So we want greater than -4, less than or equal to 5. Okay, and that is case analysis. We did 2 cases. One case didn't work out. We kept the one that did. Okay, and that's what it's going over here next for you. Okay, this is pretty important right here. I'm going to go ahead and highlight this area. We definitely want to understand this. When your inequality is greater, than or equal to 0, these are your 2 cases. Both factors are positive or both factors are negative. When your inequality is negative, these are your 2 cases. Okay? And what these are saying is, this one just simply says positive times a positive, negative times a negative, and this one says positive times a negative or negative times a positive like we already wrote out. Okay? And then keep in mind that, as we just had in our last example, it is possible to get no solution for one case. And if that's the case, then the other one probably is going to work. Okay, moving forward. Just got a little bit left here. use case analysis to solve this problem here. Well, this problem has it all. Okay, I can't GCF, so I'm going to have to go ahead and do my decomp, which doing it backwards, that's okay. Negative 15. Factors negative 15 that gets you negative 14. That's going to be negative 15 and 1. Okay, so I'm going to break that up. 5 minus 15x plus x minus 3x squared. Okay, we'll group. Take a 5 out. 1 minus 3x. Take a x out. Gives me 1 minus 3x. So now we have a factor. So here's our factor. It is 5 plus x times 1 minus 3x greater than or equal to 0. Okay, so greater than or equal to 0, we are thinking positive. This right here, we're thinking we want a positive. So that means I want plus plus or minus minus. So for my cases, okay, let's go ahead and get our case analysis box going here. So for my cases, I want to go 5 plus x. I want to go greater than or equal to 0, and I want to go 1 minus 3x greater than or equal to 0. And then conversely, on the other side, I want to go 5 plus x less than or equal to 0, and 1 minus 3x less than or equal to 0. Okay, so then I'm going to go minus the 5, so I get x greater than or equal to negative 5. I'm going to minus the 1, divide the negative 3, and now divide by negative 3 should be a trigger for you. You have to flip the inequality, so x less than or equal to positive 1/3 because of negative over negative. So here's my 2 for that side. Okay, let's go and go on the other side. Same thing, minus the 5, so x less than or equal to negative 5. Okay, this one here, minus the 1, divide by negative 3. Again, the trigger comes off. We've got to make sure we flip the inequality. X is greater than or equal to positive 1/3. Okay, so there it is. So now, let's see what they say. This one says greater than negative 5, but less than 1/3. This one says in between. This one says less than negative 5, greater than 1/3. This one says outside. So in this case, we're going to have one of them is not going to be true. So we need to test one of them. Let's go ahead and test the one here on the left first. So by testing it, let's see what we get. Let's see, something bigger than negative 5, less than 1/3. Let's go with 0. That's super simple. So 0 up here. That's going to give me 5, and then negative 3 times 0 is 0. So 1, 5 times 1. Is 5 times 1 greater than 0? It is. So this is confirmed. This side is my answer. Okay, so it's the in-between. So if we want to write that answer out, it would be greater than or equal to negative 5, less than or equal to 1/3. Just to double check, let's go try the other side. Let's try greater than or equal to 1/3. Let's go with 1. That's an easy one. So if I do 1, I'd get 6. And so I'd get 6. And I'd get negative 2. 6 times negative 2 is negative 12. Negative 12 is not greater than or equal to 0, so that would not be correct. So we can go ahead and conclude that the right side is the no solution side. Okay, and that is essentially case analysis. Let's double check here and make sure there's not any other examples. I'm pretty sure we're done. We are. Okay, so that is case analysis in a nutshell. So remember, keep track of your signs, know what they're asking. Okay, and remember, at the end of the day, what they want is they are looking for pieces of the graph. So what I want you to understand too, and just a little extra thing to add on this lesson, is that we should understand that's a negative x squared. I should know that this graph is going to be a parabola going downward. If the parabola is going downward and we want positive, then you can automatically say, I want the in-between. So when you do your work, as we did there, we got the in-between as our answer. So if you understand the concept of the graph, you're going to understand how to figure out the solution rather quickly. Okay, if you don't understand the graph, if you don't understand vertex and your parabola stuff from Unit 2, then you need to refresh that and get that going. All right, so that was Unit 2, Lesson 6, or Unit 4, Lesson 6, excuse me.